Hi there. On this video, I'm going to demonstrate how to perform and configure a site-to-site IPsec tunnel on a virtual private network. So this is part 2 of the VPN configuration. Okay, so part 1 would be the site-to-site configuration using GRI. Alright. So the prerequisite for the video is that you should have finished watching first the ENSA Module 8 VPN and IPsec concepts. So this video demo is a supplement of this ENSA Module IPsec concepts. So if you have not seen the video yet, I would recommend to see it first so that you could have the theoretical background on VPN and IPsec. So the recorded video is part of the ENSA playlist. Okay, so let's get started. Okay, so on this video, I'll be using IPsec to connect two sites or two remote sites. So before we move on with the demo, let's have some insight of what an IPsec is. So IPsec, or the Internet Protocol Security. So IPsec is a group of protocols that are used together to set up encrypted connection between devices. For instance, between two routers. Okay, so it helps keeps data sent over a public network. Okay, example is the internet. So IPsec is often used to set up VPNs, and it works by encrypting IP packets along with authenticating the source where the packets came from. So IPsec, also known as the Internet Protocol Security or simply IP Security Protocol, defines the architecture for security services for the IP network. So IPsec describes the framework for providing security at the IP layer, as well as suite of protocols designed to provide that security. So it would be through authentication and encryption of the IP network packets. Also included in IPsec are protocols that define the cryptographic algorithms used to encrypt and decrypt or authenticate packets, as well as the protocols needed to secure key exchange and key management. Okay, so let's take a look at the topology that we're going to consider on this video. Alright, so on the video, so we will be using this 3-router setup, similar to that of the GRI demo that we did. Okay, so we have here two networks, so namely the Firefly network at 192.168.1.0/24 and the Telma network at 192.168.2.0/24. So assuming that these two routers here are from distant location, so we need to establish connection or VPN using IPsec between these two routers here. Okay, and we also have the third router here. Okay, so which is a tunnel. So this would be used as a pass-through. Okay, and it's not aware that VPN exists between these two routers here. Alright, so it has several networks. You've got 192.168.1.0 here. Second would be 209.165.201.0, 209.165.200.224, and the private network 192.168.2.0 here. Okay, so we've got two private networks here, and of course the connection to the ISP. Okay, so VPN can provide a secure method of transmitting data over a public network such as the internet here. So VPN connection can help reduce the costs associated with less lines. The IPsec tunnel between the Firefly and Telma routers would be established to provide a secure connection between these two organizations here. Okay, so the ISP acts as a pass-through, as I mentioned earlier, and has no knowledge of the VPN between these two routers. So the IPsec provides a secure transmission of sensitive information over the unprotected network, in this case, the internet. Okay, so how about the procedures and the configuration? So on this demo, I only have several steps of two major procedure. First is we have to configure the basic device settings like the IP addresses, passwords, and of course routing. Okay, and then after that we need to test it before we proceed with the configuration of a site-to-site VPN configuration between routers. Now on the VPN configuration using IPsec, so we have here 6 steps. First, we have to enable the Ike policies. Okay, configure the Ike phase 1 ISAC MP policy between the two routers. So configure the pre-shared keys, configure IPsec transform set and lifetime, define the interesting traffic, and create and apply a Cryptomap. Okay, so looks like easy, right? Next, so once we have successfully configured the topology, so we could verify a site-to-site IPsec VPN configuration using the following commands. All right, so the first command is show crypto ISAC MP policy. So this is used to display the configured ISAC MP policies on the router. Second command is the show crypto IPsec transform set. So this command is used to display the configured IPsec policies in the form of transform set. So later on, along with the demonstration, so I'll be using these commands. Third is the show Cryptomap. So the show Cryptomap command is used to display the Cryptomaps that will be applied on the router. All right. So next is verify IPsec VPN operation. So we have two commands used. All right. So you've got the show crypto ISAC MPSA. Okay, so this reveals that no IKE SAs exist yet between the routers. And the show crypto IPsec SA. So show crypto IPsec SA command shows the unused SA between routers. Okay, so those are the commands that we're going to use throughout the course of the demonstration. So let's get it on. Let's get started. So this is our topology for this demonstration, and on this demo we will be using IPsec tunnel so to configure a site-to-site VPN between Firefly network and the Telma network here. All right, so we are going to start with the configuration of the interface IP addresses of the workstation. Okay, so all of the IPs are supplied here on the topology, and we just have to configure it on the client. Okay, so the configuration between the Firefly and Telma, okay, so the VPN configuration between these sites will be performed later on the configuration or on the demonstration. Okay, so let's start with the Firefly client here. Okay, so let us configure the IP address for this one. So this uses 192.168.1.1, that's /24, and our default gateway from the topology is 192.168.1.254. All right, so we're done with the Firefly client. Let's go ahead and configure the server. Okay, so from the Telma network. So to configure this, so again, the IP address are given. So this should be using 192.168.2.1. Okay, so it's /24. And default gateway would be using 192.168.2.254. All right. Now, let's do the IP address assignment on the routers now. So let's start with the Firefly network. Okay, so I used here ISR 4321 because the 1941 does not support the security features needed for the configuration. All right, so let me use this ISRs. Okay, and let's assign an IP address on this router. Okay, so would you like to enter the initial configuration dialog? So no. So let's start. So let's start with the configuration of the host name. Okay, we've got enable here, configure terminal. Okay, so host name would be Firefly, right? So, and assign an IP address. So let's activate all the interfaces here, right? Okay, this one and this. Okay, so let's proceed with the configuration. So interface G0/0/0. So IP address, this would be 192.168.1.254, 255.255.255.0. Okay, no shutdown. All right. Next is the interface serial 0/0/ or sorry, this is 1/0. So take a look at the interface name there. Right. So serial 010. So IP address would be 209.165.201.1. So subnet mask is /30. So that would be 255.255.255.252. All right. And then no shutdown. So you could include adding the bandwidth there. Okay, so but then let's just consider having the basic configuration. All right. So we're done with the Firefly router. So let's move ahead and click on the ISP. Okay, assigning it an IP address also. All right, so no. So this would be enabled. Configure terminal. Set the host name first. This is the ISP. Okay, so interface serial 010. That's our connection to the Firefly. So this would be using IP address 209.165.201.2. So this would be 255.255.255.252. Alright, so no shutdown. Okay, so next would be the connection to the Telma router. So that would be at interface serial 0/1/1. So IP address 209.165.200.225. So 255.255.255.252. Alright, so no shutdown. Okay, so we're done with the ISP. So let's click Telma here and assign it an IP address. Alright, so enable configure terminal here. Interface serial 0/1/1. IP address. This is 209.165.200.226. 255.255.252. No shutdown. Alright, so next would be our LAN. So that would be interface G0/0/0. Okay, so IP address 192.168.2.254. So 255.255.255.0/24. Alright, so what's that? IP address 192.168.2.254. Input detected. So we don't have that space there. Okay, let's do it again. So interface G0/0/0. Alright, so IP address 192.168.2.254. 255.255.255.0. Okay, no shutdown. Alright, so we're done with the basic configuration. Let us assume that you already have configured the passwords here. Okay, so of course in the production network you have to configure the password. Well, for the sake of demonstration, and this demo assumes that you are already familiar with the basic settings of the passwords and logins. Okay, so let's just skip that for now for this video. Okay, and go ahead with other configurations. All right. Okay, so let's test the connectivity now. So initially, let's test Firefly client to the Firefly router. So it's working now. So this one is working. ISP to Telma is working, and San Telmo to the server. Okay. All right, so it's working. Okay. So of course, there is no connection yet between the Firefly and the San Telmo server here. So let's do some routing configuration this time. Okay. Now this is the ISP, and we only have one connection or single connection. We call it single homed, okay, to the ISP, and therefore we will be configuring this with static default, right, and static going back to the organization. Okay, so let me start with Firefly here. So let's do some little configuration here. So we've got IP route, all right, so 0.0.0.0, 0.0.0.0. The exit interface is serial 0/1/0. Okay, so let's move to San Telmo and configure the connection to the ISP. So that would be IP route 0.0.0.0, 0.0.0.0, and then the exit interface is serial 0/1/1. Okay, we're done with the private networks. Let's move ahead and configure this ISP here. Now for the ISP, the configuration going to the organization should be static. So that would be IP route. Okay, so the network on the Firefly, which is 192.168.1.0. Okay, so 255.255.255.0. Okay, and then the exit interface from the ISP, which is serial 0/1/0. Okay, next is our static connection to the San Telmo. So again, that's IP route 192.168.2.0. So 255.255.255.0, serial 0/1/1. All right, so we're done with the routing configuration. Let's check the routing table now. Okay, we have show IP route here. Okay, so we get it. So we have two static route there. Okay, so on the Firefly, let's have do show IP route. All right, you've got the default static route in there. Okay, and last would be on the San Telmo. So let's have here show IP route. Okay, so within the config, so do show IP route. Okay, it's there. So we are assuming that the ping now between the Firefly client and the San Telmo server is not working. So let's see that. All right, it's successful, and the return one, it is successful. Okay, now if we are going to trace this, okay, so let's use the tracer here. Let's start with Firefly. Okay, so on Firefly, we're going to ping, say, ping, that's 192.168.2.1. All right, so we have now the reply. Okay, and if we're going to do the trace route or trace cert 192.168.2.1, all right, so it traverses over the ISP here. So later on, when we configure the VPN using IPSec, we should be seeing here 3 hops only. Okay, so we should be seeing 3 hops only here. Okay, so same with the previous video. Okay, so let's go ahead and test the same on the server. Okay, so on the server, we're going to ping 1.1. Okay, and that is, okay, so it's still working here. And let's do the tracer going to 192.168.1.1. So again, we have 4 hops, and we can see that it traverses via the ISP. Okay, so now that we are done with the basic configuration, okay, so IP address assignment and this time the routing. So let's move on and configure the site-to-site VPN. Okay, so the first step here is to execute the command crypto ISAC MP enable. So we want to enable the IKE policies between the Firefly network or the Firefly router and the Telma router. Okay, so IPSec is an open framework that allows for the exchange of security protocols as new technologies and encryption algorithms as they are developed. Okay, so with this, let's issue the command. Okay, so let's go to Firefly and let's type in the command here, crypto, okay, the crypto ISAC MP enable. Okay, so make sure it is supported by the router model that you're using. Okay, so IKE must be enabled for IPSec to function. IKE is enabled by default on iOS images with cryptographic feature sets. So if it is disabled, you can enable it with this command. All right, so that's why I issued the crypto ISAC MP enable command. Okay, so use this command to verify that the router supports the IKE and that it is enabled. So if the command is not working here, okay, if you are using the 1941 router and this command is not accepted, so that means the iOS does not support the crypto ISAC MP command or features. All right, now let's move and go ahead with the Telma and let's do the same here. Okay, so again, the command is crypto ISAC MP enabled. Okay, so we've got crypto ISAC MP enabled. So you can do so. For instance, crypto, and then let's see if it is supported by router. You've got crypto question mark ISAC MP is there, so that means it is supported. Question mark, you've got enable there. So enable ISAC MP. All right. Okay. So the next thing here is we need to establish an ISAC MP policy and view the available options. Okay, so what are the options supported by this ISR 4321 routers? Okay, so we are going to issue the command crypto ISAC MP policy and then the number. So assuming, okay, so we haven't changed the host name here yet. So let me change the host name here for a moment, and this is Telma. All right, let me go back to Firefly router here. Okay, so we are going to issue the crypto ISAC MP policy number. Okay, so which, for instance, we will be using 10. All right, so let's say I have here, okay, you've got crypto ISAC MP policy. All right, 10. It should be crypto. All right, ISAC MP policy 10. Okay, so with this one, this is to allow the IKE phase 1 negotiation. Okay, so you must create an ISAC MP policy and configure a peer association involving the ISAC MP policy. All right, so the ISAC MP policy defines the authentication and encryption algorithms and the hash function used to send control traffic between the two VPN endpoints here, which are the Firefly and the Telma. So when the ISAC MP Security Association has been accepted by the IKE peers, the IKE phase 1 has been completed, and then the IKE phase 2 parameters will be configured later. All right, so let's see the options available for the model of routers that we're using. So you could type in here the question mark. So these are the supported, okay, or various parameters available for the Cisco iOS. Okay, so let me resize the window here. Okay, so what are the options there? So you've got authentication, encryption, you've got group, okay, so for the Diffie-Hellman, and you've got the hash algorithm, the lifetime, okay, so set the lifetime for ISAC MP Security Association. Okay, so these are the available parameters on the Cisco ISR 4321 router. Okay, so let's move on with the configuration. Okay, so this is on Firefly. Let's say we are on the Crypto ISAC MP Policy 10 already. Okay, so we could have the hash. These are the available features here. So hash, for instance, we will be using SHA. Okay, SHA algorithm. Okay, authentication. I've got authentication here. Let me use, say, we will be using pre-share. Okay, so you'll have the options here. Okay, so authentication question mark. So you only have the pre-share, right? So no other options. So pre-share. Okay, so next, group. Okay, so let's see the group supported. So group supported are 1, 2, and 5. Okay, so let me just use one here, for instance. Okay, so you've got group 1. Okay, so that's the supported here. So let me just use that one. So lifetime. Okay, so let me use 3,600 seconds. So this is about an hour. Okay, and then encryption. Okay, so let's see the supported encryption here. You've got 3 DES, AES, and DES. So assuming that I'll be using AES. All right, so let's see the supported number of bits. So I'll be using AES 256. All right, so end. Okay, so we're done with the configuration on R1. So we should have the same configuration on the San Telmo. Okay, so let's move and go to San Telmo. All right, and do some configuration here. So make sure we have the same combinations set on the Firefly. That would also be set here on the San Telmo. Okay, so let's start the command. So again, that is crypto ISAC MP policy. Okay, so let's say policy 10. Okay, so hash would be SHA. Authentication would be pre-share. All right, and then say group would be 1. What else? Lifetime would be 3,600. Okay, so that's for 1 hour. And encryption. Okay, so AES, and I'll be using 256 bits. All right, so we're done with the configuration on the San Telmo network. Now the next is we have to verify the IKE policy with the command show crypto ISAC MP policy command. Okay, so let's do that on Firefly. Okay, so let us verify that. So verifying the IKE policy, the command is show, okay, so crypto ISAC MP policy. Okay, so this is the policy that we have configured and that we have set on the Firefly. Okay, so that would be priority 10. Okay, encryption algorithm uses AES, the hash algorithm uses SHA. Right, authentication method is pre-shared key. Diffie-Hellman would be 1. Maybe you're wondering why do we use 1. Okay, you could only use 1, 3, and 5 in here because that is the only supported Diffie-Hellman of the iOS here. So lifetime is 3,600 seconds or 1 hour. Okay, so let's go ahead and check that also on the San Telmo. Okay, so let's see, and we have to ensure that we have the same settings on both ends. Okay, so again, the command is show crypto, okay, ISAC MP policy. Okay, so let's open also this and open it side by side. Where's the other one? Telma. Okay, so let me enable this two here. All right, so let's see if we have the same settings here. So it's identical. All right. So next is we have to configure the pre-shared keys. So because the pre-shared keys are used as authentication method in the Ike policy, so a key must be configured on each router that points to other VPN endpoint. So these keys must match for authentication to be successful. All right. So the global configuration mode command, which is the crypto ISAC MP key, right? So key string, address, IP address command is used to enter the pre-shared key. So we use the IP address of the remote peer, which is the remote interface that the peer would use to route traffic on the local router. Okay. So in this case, which IP address would be used to configure the IKE peers? Okay, so let's go back to our topology. So that's what I'm saying. Which IP address should be used to configure the IKE peers given the topology diagram and the IP addressing here on this topology. Okay, so the IP address should be Firefly, which is the serial. Okay, so this one. All right, so serial 010 with address 209.165.201.1, and the other side, which is the peer, which is serial 011 to 209.165.200.226. Okay, so this addresses here, okay, both for Firefly and Telma's serial 010 and serial 011 respectively, are to be used to send normal traffic between Firefly and Telma. Okay, so let's do it. So let's move to Firefly and configure that. All right, so on the Firefly, we use the command. Okay, so let me configure this first. Configure terminal. All right, so that would be crypto. Okay, ISAC MP key. Let's say we're going to use Telma here. Okay, so that would be your password. So Telma address, so that is 209.165.200.226. so this is our peer here. Okay, so we are on Firefly and our peer is 209.165.200.226. all right, enter. Now, let's go ahead and configure Telma. Okay, so for Telma, so same, configure terminal here. Okay, so I've got crypto ISAC MP key, your password. So in this case, let me use just Telma. Address, the peer is 209.165.201.1. right? So we're done with setting and configuring the pre-shared key. Okay, next, so we need to configure the IP transform set and lifetime. Okay, so let me go back to Firefly again and let's see what are the available combinations or combo here. Okay, so configuring the IPSec transform and lifetime, so we'll have the command crypto, all right, IPSec, we got transform. Okay, you could use tab instead. So transform set, let's say we'll be using transform set 50. Okay, and what are the options? So here are the options and the combo. Okay, we've got AHMD5 HMAC. Okay, so those are the features supported by the router. Okay, so between Firefly and Telma, So we are going to create a transform set with tag 50. Now I used 50 here and use ESP transform, okay? ESP transform with an AES, all right? 256 ESP SHA HMAC. Okay, so let's see that. So again, that's crypto IPsec transform set 50 followed by ESP, all right, AES 256, okay, and ESP SHA HMAC. All right, so let me expand this window here. All right, so that you'll have a one-line command there. Okay, so we have to do the same again on the San Telmo. So let's move ahead and go to San Telmo, not the server, but the router here. Okay, so let's configure also the transform set. Again, the command is crypto IPsec, okay, transform set. The number was 50, right? So 50 ASP AES 256 bits ESP SHA and HMAC there. Transform, it should be transform set. All right, now if you are asked what is the function of the IPsec transform set that we configured here, okay, so the IPsec transform set specifies the cryptographic algorithms and functions, right, or transforms that a router employs on the actual data packet sent through the IPsec tunnel between Firefly and San Telmo. So this algorithm include the encryption, okay, so we have the combo as what I've said earlier. This includes encryption, encapsulation, authentication, and data integrity services that IPsec can apply. Okay, now if you have some difficulty or challenge, or if you are challenged about the terms and the combinations here, again, the recommendation is to go ahead with the VPN discussion on the ENSA Chapter 8. Okay, so that is the prerequisite of this video demonstration. Okay, so next would be, let's say we want to change, we have set the lifetime, right, to 3600 seconds earlier. Okay, so we can change the IPsec Security Association lifetime from the default. The default is 3600 seconds, or that is approximate, or not approximately, but exactly 1 hour. Okay, so for example, on Firefly, okay, so, and on San Telmo, we want to set the IP Security Association lifetime to 30 minutes only. So that's about a half, okay, and that is 1800. So let's do that. You can also set it here. Okay, so let's go back to Firefly and set it. So again, the command is crypto IPsec Security Association. You could just use the tab here. So crypto IPsec Security Association lifetime, okay, seconds, that would be 1800. Okay, so let me adjust this. Again, the command was crypto IPsec Security Association lifetime seconds 1800. Okay, we want to reduce it from having 1 hour into 30 minutes. Okay, next we'll do the same on the San Telmo. Okay, so take note that this configuration should be identical at both ends. So again, the command was crypto IPsec Security Association lifetime, okay, seconds 1800. Okay, so we're done. So the next one would be, we have to define the interesting traffic. Okay, so interesting traffic, this is to make use of the IPsec encryption with the VPN. It is necessary to define the extended access list to tell the router which traffic to encrypt. Okay, so a packet that is permitted by an access list used for defining the IPsec traffic is encrypted if the IPsec session is configured correctly. So that's our objective here. Okay, because with IPsec everything is encrypted, unlike in GRI. All right, so a packet that has been denied by one of these access lists is not dropped, it is sent unencrypted. Okay, so also like other access lists, there is an implicit deny at the end of the statement, which means the default action is to not encrypt traffic. So if there is no IPsec security association correctly configured, no traffic is encrypted and the traffic is forwarded unencrypted, or it's unsecure. Right? So on this scenario that we have here, okay, so from the perspective of Firefly, the traffic you want to encrypt is going from Firefly's Ethernet, okay, Ethernet's LAN to San Telmo's Ethernet LAN, and vice versa. We're talking about this Firefly network and the San Telmo network here. Okay, so this access list are used to outbound on the VPN endpoint devices or interfaces and must mirror each other. So we have to have the opposite configurations when it comes to IP addresses. That's what we call mirroring here. All right. So let me go ahead and click on Firefly, and let's do that. Let us define the interesting traffic. Okay. Now, in defining the interesting traffic, so we will be using the access list. Now, we need to create an access list. For instance, I'll be using access list, let's say 101. Okay. So you got permit. So access list permit IP. Okay. So what do we want to permit here? So we want to permit 192.168.1.0 to reach 192.168.2.0 here. All right. So let's do that. That's 192.168.1.0. All right. And that's /24.0.0.0.255. Okay. Destination would be 192.168.2.0. That's /24. So again, that's 0.0.0.0.255 there. Okay. So we're done. So this is on Firefly. So that's the direction would be from this. Okay, so Firefly network to San Telmo network. Okay, so let's go ahead and click on the San Telmo this time and do the mirror configuration. Okay, so let me adjust this. All right, so let's start. So again, that would be access list. Okay, so 101 permit. So we want to permit 2.0 192. Okay, let me put some space there. 192.168.2.0. Okay, so that's 0.0.0.255 to 192.168.1.0 0.0.0.255. Again, let me adjust this one. So here's the command. Permit IP. So we forgot IP here. All right. Okay. Now, so after configuring that, after defining that interesting traffic, if you're asked, does IPsec evaluate whether the access lists are mirrored as a requirement to negotiate a security association? The answer is yes. Okay, so IPsec does evaluate whether access lists are mirrored. So IPsec does not form a security association if the peers do not have mirrored access lists to select interesting traffic. So make sure when you configure on the other side, it should be the opposite of the configuration. So for instance, in here, San Telmo, this is from San Telmo network going to the Firefly network. So on the Firefly network, that would be from the Firefly network going to San Telmo. Okay. All right. So next step would be to create a Cryptomap. Okay. So Cryptomap associates traffic that matches an access list to a peer and various IKE and IP settings. So after the Cryptomap is created, it can be applied to one or more interfaces. So the interfaces that is applied to should be ones facing the IPsec peer. So we would be using the command Cryptomap, name, sequence number, and type. Okay, so let's go back to Firefly. All right. Okay, so let me extend it so that we could have a one-line view. Okay, so create a Cryptomap on Firefly. Okay, and we name it San Telmo. Okay, let's say we name it San Telmo. And we are going to use 10 as the sequence number. So a message display after the command is issued. Okay, so with something like this new Cryptomap blah 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 will remain disabled blah blah blah. All right, so let's have it. So you've got crypto map. Let's name it San Telmo. Okay, Cryptomap San Telmo. So you've got 10 IPsec, right? ISAC MP. Okay, so this is what I'm saying earlier. Okay, next. So match address. The access list that we defined earlier is access list 101, right? If I remember it right. Yes, it's access list 101 here. So therefore, address 101. Okay. So to view the list of possible set commands that you can do with a Cryptomap, so again we could use the set. Okay, set question mark. So these are the supported activities there. So that is if the match address 101. Okay, we're going to set peer. Okay, so you've got set peer. So the peer would be, okay, so this is in Firefly. So the peer would be 209.165.200.226. All right. So next is we have to use the set transform set tag command to hard code the transform set to be used with this peer. So we are going to set the perfect forwarding secrecy type using the set PFS type command and modify the default IPsec security association time or lifetime with the security association lifetime seconds command. Okay, let's do it here. Okay, so set peer 209.165.200.226. So we've got set PFS, okay, group 1, right? We used 1 on the Diffie-Hellman earlier. Okay, so we've got set transform set. Okay, transform set number that we use is 50, right? So that would be 50 set security association, right, lifetime. Okay, so let's make it 900. Okay, lifetime, sorry, you've got seconds there, 900. All right, and then we have to do the same on San Telmo. Okay, so let me show the configuration, the complete configuration on San Telmo here. Okay, so of course doing the opposite or the mirror. Okay, so the command was crypto. Okay, crypto map, the name was San Telmo. Okay, so 10 IPsec ISAC MP. Okay, all right, so that would be match address 101. Okay, set peer, our peer is the opposite this time, so we are San Telmo, so this is our peer, 209.165.201.1. You've got CPFS group 1, Sorry, it's group 1. Okay, and then set transform set, that was 50, and set security association lifetime seconds, that's 900 here. Okay, and then exit. Okay, so after we have created, okay, so the Cryptomap, okay, so we are going to apply it on the interface. Okay, so let's go back to Firefly and let us apply this on the interface. So the interface, that would be, all right, so interface serial 0 slash, again, what is that? Let's check. Serial 010. All right, serial 010. Okay, so to apply, that's Cryptomap San Telmo. Okay, so if you'll observe here, the Cryptomap ISAC MP is on, and it is on effect now. Okay, so next, now let us apply and do the same on San Telmo. All right, so in here, that would be interface. So let's check the interface here. Serial 011. All right, so that would be interface serial 0 slash 1 slash 1. Okay, and then crypto map, the name of the map was San Telmo. All right, so ISAC MP is on, and then you've got end here. All right, so we're done with the configuration. Okay, so since we're done, let's verify the site-to-site IPsec configuration or the VPN configuration. So let's move ahead and go to Firefly and issue the command show crypto IPsec transform set. Okay, so we want to verify the configuration, so those show, okay, crypto IPsec transform set. Okay, so here we go. So transform set 50, you've got the ESP256. all right, so that's what we set, right? So next is we have to ensure that we will be getting the same on the San Telmo. Okay, so let me have San Telmo here. Let's see. You've got show crypto IPsec transform set now. Okay, so we've got show crypto IPsec transform set, enter. Okay, so let's place it side by side, Firefly and San Telmo. Right, so next is we use the command show Cryptomap, okay, to display the crypto maps that will be applied to the router. So let's go back to Firefly and let's issue show Cryptomap. Okay, show Cryptomap. All right, so Cryptomap named is San Telmo. All right, so and here's the allowed, okay, addresses. Okay, so also on San Telmo, let's do the same, show crypto map. Okay, so again, the interfaces, so you have to be very careful on the selection of the interfaces. Okay, now let us verify now the IP VPN operation. So on R1, okay, which is our Firefly here. It's our first router. Okay, so that shows the command show crypto, okay, ISAC MP SA. Okay, so show crypto ISAC MP SA. So that means there is no IKE SAs yet. Alright, so no IKE SAs yet. So when interesting traffic is sent, this command, okay, or this output here will change. Okay, so let's see. Let's also do that on the San Telmo. Okay, so show crypto ISAC MP, okay, security association. So there is no security association yet. Okay, again, so when the interesting traffic is sent, then we're gonna have the associations, and that would be displayed there. Okay, next we can use the command show crypto IPSec SA. Okay, so it's here, and there is no association. Now let's do some and generate some interesting traffic here, and let's observe the results. Right, so what we're going to do is to ping from Firefly. Okay, let me go ahead and click on this Firefly. We are going to ping to San Telmo. Okay, so we are going to ping San Telmo serial 011. Okay, so let's see if this would be successful. Let's do that. Gonna ping 209.165.200.226. Okay, now let's issue the show crypto ISAC MP SA. Show crypto, okay, ISAC MP SA. Okay, and then let's ping from R1, which is the Firefly, to the San Telmo's LAN or network here. Okay, so let's do it. We got ping, okay, 192.168.2.254. Okay, so successful. Okay, now let's issue again the show crypto ISAC MPSA. Where's that? Okay, now question: was an SA created for these pings? Did we get a security association? Okay, so take note that we don't have security association created there. That is because the source address of both pings was from serial 00 or serial 010. Okay, so take note that the interesting traffic would be coming from the Firefly network. So this is what we have defined on the access list. Okay, 192.168.1.0 to 2.0. Right? Okay, so let's generate some interesting traffic. Okay, so let's do the extended ping here. So ping, okay, so IP, target IP address is 192.168.2.1. For instance, that is the server. Okay, so take note that we are generating the interesting traffic here, and there should be association now after we do this. All right, so that would be 192.168.2.1, so which is our target. Okay, enter. Repeat count 5, diagram or datagram size is 100, so time 2. Extended commands, yes, okay, because we want to specify the source or the interface, which is 192.168, okay, that what is that, 1.254. Okay, so LAN. Okay, so and just accept this. All right. Can we ping? 80%. Okay, so at least there was association there. So, okay, let's see if there is an association now. So let's type in again the command earlier, just show crypto ISAC MP SA. So we have now here, okay, so the association. All right, so that is because the traffic was originated from the Firefly network going to the San Telmo network. Okay, so this is what we have included on the access list. All right. Okay, so we have the association. Let's close this. Take note that before we configure this, let's go back to the command prompt. All right. So in here we have 4, okay, hops. So that means the traverses on the ISP. So same thing also with this is Firefly. Let's go ahead and click on San Telmo. Okay. On the San Telmo, sorry. So we need the client or the server from San Telmo. Okay. So earlier on, before we configure the IPsec, all right. So we see that we have 4 hops. Now that we have successfully configured the IPsec VPN, let's do again the tracert. Okay, so tracert 192.168.2.1. So we are expecting that we have 3 hops here. Okay, so that means the traffic is traversing via the tunnel. Okay, so like what we did with the VPN GRI. Also, on the San Telmo server, so let's do the same before we configured the IPsec. So we have here 4 hops traversing over the ISP. So this time, so let's redo the tracert going to 1, and you have 3 hops. All right, so that's it. That's it. Thank you for listening. Have a great day.